video is about performing basic matrix operations. A matrix is a way of organizing an array of numbers. So let's say, for example, that you have measured the height and weight of 3 different people. And maybe the first person is 5 feet tall and weighs 120 pounds. The next person is 5.5 feet tall and weighs 150 pounds. And 6 feet tall, maybe weighs 220 pounds. And so these are 3 people you know. You've measured their heights and weights. You could arrange these numbers in a matrix by opening up a square bracket, and in our first row, we'll put everyone's height, 5, 5.5, and 6. And in our second row, underneath those, we'll put the corresponding weights. And this is what a matrix looks like. In a set of square brackets, it has rows and columns. In this case, each column represents a person. The first row is their height, and the second row is their weight. So this is just an example of a matrix. They're used a lot in math. Today we're going to learn how to do operations, some basic operations with numbers arranged like that. To classify the size of a matrix, we use its dimensions. It's rows by columns. A row is a horizontal line, so these are rows. A column is vertical. So we're going to count up that in this first example, we have 2 rows, we have 3 columns, and so we would call this a 2 by 3 matrix. That's how you would read it, a 2 by 3 matrix. That's how you classify the size. The second example, I count 1, 2, 3 rows, and 1, 2, 3 columns, so this would be a 3 by 3 matrix, sometimes called a square matrix. And the final one is I only count 1 row, but 1, 2, 3, 4 columns. So this would be a 1 by 4 matrix. If matrices have the same dimensions, and that's why we did that first, they can be added or subtracted. If the rows and columns aren't the same, then you can't add or subtract the matrices together. In this first example, both matrices have 2 rows, 3 columns. So they're both 2 by 3, which means I can add them together. And my final answer will also be a 2 by 3 matrix. To add matrices together, you take the first element in the first row and add it to the first element in the first row of the other matrix. It's very straightforward. Then you take the second element of the first row, add it to the second element of the first row in the other matrix, and so on. 1 plus 2 is 3, -4 plus 0, 5 plus -1, and 2 plus 5. So my resulting matrix is still a 2 by 3. This next example we're subtracting, it works the same way. They're both a 2 by 1 matrix, which means my answer will be a 2 by 1 matrix. -1 minus a -4, which is like adding, and 12 minus -5, which is like adding. So our final result is a 2 by 1 matrix. Any matrix can be multiplied by a constant, which is called a scalar when you're doing matrix math. So this 2, the constant that we're going to be multiplying by, is called a scalar because we're using it to scale up the matrix or scale it down. So we're scaling it all up by 2 here, which just means I'm going to distribute a 2 through the matrix. So a 20, 14, and -8, -4, 0, and -10. The resulting matrix is still the same dimensions, 2 by 3, that it started as. This scalar is a 1/2, so I'm scaling everything down, multiplying it all by a half. -4 times a half is -2, and -5 times a half. So my resulting matrix, same dimensions as the starting matrix. Then we can apply these skills to solve a basic matrix equation. So in this equation here, I have a -2 out front, that's my scalar. In parentheses, I have the addition of a 2 by 2 matrix to another 2 by 2 matrix. And then on the other side, I have a 2 by 2 matrix. I think the first thing I want to do here is get rid of that -2 that's in front. Now, rather than distributing it through the entire thing inside the parentheses, I notice that the right side, all of the numbers in this matrix are nice, even numbers. So I think I'm going to go ahead and multiply both sides by -1/2 to get rid of this -2. Multiply by -1/2. So this will cancel out. That means the parentheses can go away, and on the left I have my 2 matrices that were being added together, which I will do in the next step. For now, I'll leave them. And on the right, my matrix is getting multiplied by the scalar on -1/2. So I end up with -6, -5, -1, and +9. On the left, I'm going to go back to simplify this side of the equation. I've got two matrices that can be added together, so I will. -3x plus 9 goes in my first element. -1 plus -4, 4 plus -5, and y plus 3. Can't simplify that any further just yet. And now you should notice I have a 2 by 2 matrix equaling a 2 by 2 matrix. And if you look at the elements that we actually have completely solved, we've got -1 here corresponding with a -1 here. And we've got a -5 here corresponding with a -5 here. So these matrices are going to be equal. We just need to solve the equation for x. The equation for x is going to be the element from the first row in this matrix has to equal the element 1 from the first row in the answer matrix. So I'm going to solve this equation. -3x equals -15, and x equals 5. The equation to solve for y is going to be that this element equals 9, so y plus 3 equals 9, and therefore y equals 6. So we've solved our first matrix equation just using the basic operations that we learned in this video. And that is it.